Hey guys, Mr. B here again, bringing you another awesome math to do here on this stormy night. Big storm out this way. We have lost a lot of school in the last month, and unfortunately for my students in my class, that means a lot of homework. Alright, so currently in my class we're doing trig derivatives and calculus. So I thought I would do a little proof for you guys, and the proof I'm going to do is that the derivative of cos of x is equal to negative sine of x. So, generally how all these proofs start, they start with the definition of derivative. So, definition of derivative is f prime of x is equal to the limit as h goes to 0, f of x plus h minus f of x all over h. Alright, so let's go ahead and fill this guy in. So I'll start with my d over dx of cos of x, and then I have the limit as h goes to 0, and I go ahead, I'm going to sub this guy, my cos of x, into this guy. So I'm going to take the first step is to take my function cos, so cos is my function, and I'm going to substitute in for x plus h, and then my f of x is just cos x all over h. So now what I need to do is I need to rewrite this guy cos of x plus h. So that is one of my sum formulas. Cos of x plus h is the same as cos of a plus b. So cos of a plus b, or cos of x plus h, is the same as cos x cos h minus sin x sin h. So I'll take this guy and replace that over here. So I have limit as h goes to 0, cos x cos h minus sin x sin h minus cos of x. So you got to be careful with your subtraction and stuff like that in this guy. So very similar to the cos proof, what I'm going to do, or sine proof, sorry, the derivative of sine, I'm going to take these two guys and this guy and sort of combine them up so I can do a little factoring. So the limit as h goes to 0, take the cos x cos h minus cos x minus sin x sin h all over h. So right here, what I'm gonna do basically is I'm gonna factor out a cos out of this, just these two guys, and I'm actually gonna separate that h so it divides these two things individually. So I'm gonna make two fractions out of it. So the limit as h goes to 0, cos x cos h minus 1 all over h, and minus sin x sin h all over h. And I'm going to put brackets around that to show that that limit applies to both of these guys. So the limit applies to both. You could actually write the limit in front of both if you want, but I'm going to leave that for this step. So now I'm going to distribute the limit, and I'm going to rewrite these h's a little bit different. So the limit as h goes to 0, and I'm going to write the cos x a little bit by itself, and then I'm going to put the h simply with this, because I know what that limit is right there. And I'm going to do the same thing, rewrite my limit, and then I'm going to have sin h over h, just like that. So now what I need to do is just recognize, so the reason why I did that is because I want to match up my h's. So before I get ahead of myself, the reason why I did that, I just want to match my h's. So now what I want to do is, since these cos x and this sin x do not have an h in them, I can take them outside the limit sign. So they're not going to change once I evaluate my limit. They're essentially constants because my limit are going to, it's going to 0. Now they're not technically constants, of course, because they have a variable, but for the sake, the limit will not change them once I evaluate. And then I have, so I took the sine out, took the cos out, then the limit as h goes to 0, sin h over h. So these limits I know. I know what this limit is, and I know what this limit is. So the limit as h goes to 0 of cos h minus 1 over h is actually equal to 0. And the limit as h goes to 0 of sine h over h is actually equal to 1. So these are like known given limits in trig derivatives and trig proofs and trig limits. So if you're looking for a proof of these guys, you're going to have to check out another video. But for the sake of this proof, we can accept them as true, and that's what most people do because they are true. And we can't spend our entire proof proving things. So we'll go ahead now and sub those in. So 0 minus sine x times 1. And then this goes away. And then I have negative sine x left. So there it is. So the derivative of cos is equal to negative sine. Nicely done. So guys, now that you have this proof and you know a few probably trig derivatives, you just need to memorize them and be able to apply them. Alright, thank you guys for watching. See you guys in class.